Hello everyone. I'm a little angry right now because this is the second time I've had to make this video. I used another app to do this. It was like a half an hour video and then it only recorded audio. So we're trying this on a different app. So if I forget something, it's because I was like, oh, I've already said it when I really said it in the other video. This app is a little bit new. I've used this app many times, but this is a newer interface. So please, please, please be patient with me. Thank you. And I am also figuring out how to edit with this app, which is something I just did because I just made a mistake. Anyway, you know what? Let's just get started. So this is going to be day 1. Oops, that's not how that's spelled. There we go. Day 1, inverse, trig, and we're going to be taking a look specifically at solving. Please let me know how the sound is. I don't know if like the tapping of the iPencil is annoying or just, I don't know, let me know. Anyway, so when you are solving, you are doing a few different things. So let's take some notes about solving, trig, equation. So here's what we're going to want to know. There are in fact 2 things. You're going to want some normal algebra. Don't make up any algebra. I know some of you like to do that. Normal algebra to isolate a trig function. I'm going to add a little note that says preferably 1, because sometimes you will be dealing with problems that have more than 1. And the second thing you're going to do is you're going to want to find all possible solutions between 0, and 2 pi. So looking at the interval of including 0, all the way to 2 pi, but not including 2 pi. So as we've talked about in the past, many people, when I say, hey, like what is cosecant to sine? A lot of people are like, it's an inverse. Tis not an inverse. That is a reciprocal. So just a reminder, inverses, if we say something like f of x, we say that as f of x. If you see this notation with the -1, that is f inverse of x, but I'm going to try to change colors here. Yeah. Actually, no, let's do green. Green sounds like fun. But if you see, ooh, that is bright. Ooh, goodness. Okay. Trig inverses, it's also going to have that little -1 there. So if you take a look at like a calculator for like your sine, cosine, and tangent buttons, you'll notice just above them will be sine inverse, cosine inverse, and tangent inverse, because that's what an inverse does. It just undoes, quote unquote, that particular function. So that's what those inverse pieces do. And so all we're doing today is just solving. I have 4 examples for you. Let's see what we can do. Let's move all of this up. Oh, it's changing in size. Okay, that's a thing as well. Sorry, I'll move that to about here. So we're going to draw a very rough sketch of, oh, that has to be back on the pen. A very rough, that's the highlighter. All right, see, we're learning things. Rough sketch, pardon me, of sine. So let's see when we do that. We'll say that's 1. That looks to be about -1. And it's going to look something... Again, oh, that's too rough, All right. We'll do that. We'll just boop-a-doop-a-doop. All right. Again, I'm really hoping you're enjoying these sound effects. Yeah, you know what? Sure, we're going to say that's good. where, let's see, this right here is 2 pi, this is 0, and that's negative 2 pi. Now, we're going to take a look at this graph while we are solving, and that may be able to help see kind of where some of our information is coming from. You may also want a unit circle with you. Going back to the back. All right, so let's take a look at example number 1. That's going to be 2 sine of x minus 1 is equal to 0. Our goal here is to get x by itself. So we're going to add 1 to both sides. We're going to divide both sides by 2. Oops, actually, you know what? I'm going to erase that. Come on. And I'm going to just move it over here. So we get to here. Now, we still have to get x by itself. So we have to find a way to undo sine, which is the inverse piece. So I'm actually going to change my color here. So we need this inverse piece. So I'm going to use sine inverse and apply that to both sides of my equation. Now with the sine and sine inverse, those cancel each other out, just like multiplying by 3 and dividing by 3, or adding 1 and subtracting 1. They cancel out. So we are going to be left with x is equal to sine inverse of 1/2. Now what this means, x is going to be our angle. So the question is, at what angle is sine, or in this case, our y value, I was about to write y-intercept, our y value is whatever value this is. In this case, 1/2. So at what angle is our y value 1/2? Please take a moment, pause the video, find those answers. Okay, so you are in fact going to have multiple answers, and that's okay. Sometimes the problem will have no answers, 1 answer, 12 answers. So really it's somewhere in between. Sorry, you can probably hear my phone. So here, if x is equal to pi over 6 and 5 pi over 6. When I'm looking for a final solution, we are going to start putting our solutions in solution sets, just because many of our answers will be coming from multiple places. So when you're putting things into a solution set, please make sure that you are putting them in order of least to greatest. If you would like another way to visualize this, you can take a look at our graph up above. So we're looking to see when our sine function is 1/2. So if I stick a little 1/2 right here and kind of let that play out across the graph, remember we're only looking between 0 and 2 pi, you're going to have an answer here and an answer here, being at pi over 6 and 5 pi over 6. So if it helps draw the graph, you can do that as well. So let's see, that was our first example out of 4. We have 3 more to go. Sorry about my phone. Let's get going. So let's see if we move this up to here. Maybe I can make it a little bit smaller. Let's start on, oop, that's still in the red pen. Example 2, and again, thank you for your patience. Example 2 is going to be 3 times tangent squared of x minus 1 is equal to 0. Because we can use any of our 6 trig ratios, we won't always be using one on the unit circle. So here, I'm going to start in the exact same way. You're going to add 1 to both sides, divide both sides by 3, and then we look at this. There's going to be something y'all forget. Please do not forget it when you are solving, and you need to square root something. So in order to get rid of this squared, we're going to square root both sides, and many people are going to give me the answers of tangent of x is equal to the square root of 1/3, which like mostly right, but not completely right. What you're going to forget, and please, please, please do not do it, is the plus or minus. This right here, super duper important. Do not forget that. Okay, so that's that plus or minus. The reason that's so important is because if you don't put that there, you're losing half of your answers. If there's already a square root in the function, you don't need to do that. But if you're solving and you need to apply a square root, add the plus or minus. But you may look at this and be like, this does not mean much to me. So let's go through and simplify this. So this is going to be the positive and negative version of the square root of 1, which is just 1, over the square root of 3. And you may look at this and go, oh no, no square roots in the denominator. So you're going to rationalize this and say this is really the positive and negative version of the square root of 3 over 3. Now, you may recognize this from last unit when we filled out a table for the first quadrant of the unit circle for all 6 trig ratios. But if you don't remember exactly where that comes from, let's see, let me grab a different color. Let's do blue. This right, oh, I like that shade. This right here is, we got that from going 1/2 divided by root 3 over 2. And remember, tangent is the same as sine over cosine. So if it is a little difficult for you to think where in my unit circle is tangent root 3 over 3, another way to think about that is when is my sine or y value 1/2, and when is my cosine value, or x, root 3 over 2. So that's where we get that from. But anyway, what we have here is 2 separate problems. Let's see. Go back to black. There we are. So this is really tangent of x is equal to the square root of 3 over 3. And tangent of x is equal to the negative version of square root of 3 over 3. You don't have to separate them like this, but it kind of helps me visually. So now let's take tangent inverse on both sides for both of these equations. So this will be x is equal to tangent inverse of root 3 over 3, and x is equal to tangent inverse of negative root 3 over 3. You can take the extra step of applying tangent inverse to both sides. However, you do not have to. I am fine with this. So I'm going to give you a moment to find that. Okay, sorry, you should have paused the video. Also, when I'm in here and like silent for a few seconds, I'm kind of dancing. So when you get your answers, you should get, for your positive one, pi over 6 and 7 pi over 6. And for your negative version, you should get 5 pi over 6 and 11 pi over 6. So these are our answers, but again, we're putting our answers into a solution set. Now, I'm not putting the answers just like this in a solution set. I'm going to list them from least to greatest, and this will kind of help us in our arrangements. So I'm going to say my answer is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So that is my final answer. This is the type of work that I want to see from you. There will be problems like this on your homework. All right, 2 more examples to go. Let's see. Oh, I can move this without pressing the finger button to say movement. Oh, that's good. Okay, so I'm going to move that to like there. Sorry, I know it's a little shaky. I apologize. Okay, so example number 3. Example number 3. This is a fun one. We've got cotangent of x times cosine squared x is equal to 2 cotangent of x. Now, remember earlier when I said we might have more than one trig function? There you go. And some of you might be like, Miss Wayne, why do you do this to us? Counter argument, why not? You can. I believe in you. So when we take a look at this, our first instinct might be to say, oh, there's a cotangent on one side of the equal sign and the other side. Let's divide both sides by cotangent. No, do not do that. Never, big capital letters, divide by a function to cancel it out. So if, for instance, if there was like a 2 on both sides of the equation, so that's something you can divide by. But if it's a function, do not divide both sides by that function. You will be losing some of your answers. So what we're going to do instead is we're going to subtract 2 cotangent of x on both sides. So we end up with cotangent of x times cosine squared x minus 2 cotangent of x is equal to 0. Now, algebra. Algebra is very important. This is a thing that messed us up last unit with verifying. This messed us up for logarithms, and this also messed us up when we were finding inverses in our very, very first unit of the year. So I'm going to do an example off to the side. If I have something like x squared minus x is equal to 0, and I asked you to factor this, or I asked you what do these two things have in common, I would say x. So I'm going to divide an x out of both of these pieces and get x minus 1 is equal to 0. So that's what I'm going to do here. Both of these have a cotangent, so I'm going to divide both sides over here by a cotangent of x and say, hey, I'm dividing by cotangent of x. What am I left with? Well, this first piece, cotangent of x times cosine squared x divided by cotangent of x, that's just going to leave us cosine squared x. And then our second piece over here of negative 2 cotangent of x divided by cotangent of x, well, it just leaves us with negative 2. What we're really doing is factoring, but this is something that it's difficult for a lot of us to see. So that's one of those algebra steps I really don't want you to miss. Going back to my algebraic example on the right over here, if I asked you to solve for x or get x by itself, another way of asking that is, what is the x-intercept? So I can solve for that by saying, well, let's set our factors equal to 0. So x is equal to 0, and x minus 1 is equal to 0, and I would solve from there. So for our example, I'm going to say set both of these factors equal to 0. So we have cotangent of x is equal to 0, and that's the first piece. I'm actually going to take my work and divide that in half. Ooh, I can move it like that. I'm going to divide this in half. Yeah, that's probably good. And then have cosine squared x minus 2 is equal to 0. So now I've taken this really complicated looking problem and split it up into two smaller, less scary looking problems, which is really nice. So let's see, we are going to start on the left side of this equation. Just a reminder, cotangent is your x value over your y value, or your cosine over your sine. So if we were to draw a unit circle, let's use yellow. Let's see what that looks like. Oh, it's a pretty decent yellow. Not a decent circle, but a decent yellow. So if we're doing cosine over our sine, I need to make sure that my y value is not going to be 0, because dividing by 0 is bad, but our x value has to be 0. So the only places where we have our x value of 0 is here, at 0, negative 1, and here, that's a positive 1, sorry, my bad. We're just going to erase that. Beepity. There we go, that's a 1. And 0, negative 1, there we go. So these pieces here, so when we are solving, we'll have to cotangent inverse both sides, and we get x is equal to cotangent inverse of 0, and these are going to be the two places where cotangent is, or your x over your y, is in fact 0. So when we list those, we'll say that our angle can be pi over 2, which is the top part, or 3 pi over 2, which is the bottom part. So that is our answers for the, so those are our answers for the left side. For the right side, let's solve as we normally do. Let's add 2 to both sides. So cosine squared x is equal to 2. And then from here, I see a squared, which means we're going to have to square root both sides. And do not forget, say it out loud. I don't care where you are. Say it out loud right now. What are you not supposed to forget? You are not supposed to forget that plus or minus right there. So please do not forget that plus or minus, all right? But what we can really do here is separate these out again and say this is cosine of x is equal to the square root of 2, and cosine of x is equal to the negative square root of 2. So we've taken this part of this problem and split it up even more. Why not? Because I definitely think we can. I'm going to move this just a little bit. Okay, so we're here. We're going to cosine inverse everything on both sides. So we get x is equal to cosine inverse square root of 2, and x is equal to cosine inverse the negative square root of 2. It's absolutely beautiful. Take a moment, try to plug this in your calculator. Pause the video maybe. Okay, so you will notice that there is some type of error. Math error, domain error, something like that. This is a case of a no solution. And the reason being is that if we were to very much, again, rough sketch a cosine graph, where this is 1, negative 1, all right, that's a real rough sketch, but there's our cosine graph. It looks something like this. Well, square root of 2 is about 1.4-ish. So what we really have is about right here is the square root of 2. And about right here is the negative square root of 2. So if I'm saying, hey, where does this happen on our graph? It doesn't happen anywhere, which is how we get a no solution. So our only answers for this problem, when I put it into my final solution set, are pi over 2 and 3 pi over 2. So you may be a little mad at me that we did all that work and only had those first two answers, but you know what? That's okay. Again, feel free at any point to pause this video. We got one more example. You can do it. I believe in you. I'm going to move this information up right now so we can have space for our last example. I'm going to pause this. There. Okay, so very last one, example number 4. It is going to be sine of 2x is equal to the square root of 3 over 2. Now you might see this and go, oh, 2x, that's a double angle. We've used those identities last unit. I should just grab that sheet out. Not yet. We'll get to that eventually later in the unit, but right now you're going to make it way too hard on yourself. Since we're just solving for x, undo what you can. Let's just use sine inverse on both sides. You get 2x is equal to sine inverse of root 3 over 2. Now, what that 2 means, and we're going to change color again. I really like that blue. So what that 2 means there is instead of finding all solutions for just one unit circle, we're going to find all solutions for 2 full rotations of a unit circle. So instead of finding all the answers between 0 and 2 pi, you're going to find all the answers between 0 and 4 pi, so 2 full rotations. So right now, find all the values of when your, all the angles for when your y value is root 3 over 2. Pause the video. Okay, so this is what we end up with. We end up with 2x is equal to, let's see, on our original unit circle, sine, or our y value, is going to be root 3 over 2 at pi over 3, as well as 2 pi over 3. But if you go another rotation, you'll find more answers. And going another rotation means finding a coterminal angle, just like in our first unit from this semester. So I'm going to do a little bit of side work over here. I might say that pi over 3, and I might just want to add 2 pi to that to find my other answer. Or in this case, pi over 3 plus 2 pi, that's the same as pi over 3 plus 6 pi over 3, just finding common denominators. And in this case, that would be 7 pi over 3. So another one of our answers is 7 pi over 3, just going that extra rotation. And then if you wanted to add 2 pi to the 2 pi over 3, you are going to end up with 8 pi over 3. So these are all the answers we have for 2 full rotations, but we still have to solve for x. So I'm going to multiply both sides by 1/2. You can just divide both sides by 2 if you want to. However, there we go. However, that's going to give you a triple fraction, and those are sometimes kind of tricky. So multiplying by 1/2 is the same as dividing by 2. And that's going to get us x is equal to pi over 6 times 2 pi over 6 times 7 pi over 6 times 8 pi over 6. And from here, if you can, please reduce. So, for instance, 2 pi over 6 becomes pi over 3, and 8 pi over 6 becomes 4 pi over 3. And you will notice that all of our final answers are still between 0 and 2 pi, just like they should be. But we're not done yet. Please put your answer in a solution set. Oops. Please give me the reduced version, that was my bad, in the solution set, so that will be 4 pi over 3. So feel free to watch these videos as many times as you want. These are just a few examples. Let me make that look like a better 7. These are just a few examples of problems you might see in the homework. So please go to Canvas and look at the inverse practice section. Also, just to know that you made it to the end of the video, next week, meaning the week of April 13th, when we have class on Zoom, if you could please greet me with the word pumpernickel, I will know that you have made it to the end of this video. Again, next week, the week of April 13th, when we have class, please greet me in our Zoom meetings with the word pumpernickel. Hope to see you soon.